So in the previous video, we left off with this program, and we talked about how we could force the integer data type into a string class-like object or a string variable, um, and so we you know we could have turned this into we could have kept it at 8.5 and output would be 8.5. So but let's go ahead and see what happens when we try to convert this to 8.5 and say 9.8. And as you can see, even before we try to compile anything, we have a get an error, and the compiler is telling us maybe we should change the num2 into a double. Well, and as we talked about, um, a, a double takes up uh, literally double the space of a of a float or a floating point number data type. A float takes up only 4 bytes. A double takes 8 bytes of information. Has greater precision in how many decimal places you can actually store. But say we wanted to actually force the force, or actually let's see here. Let's type in float and to actually get what I was talking about. So see here, it's saying maybe we should turn the float into a double, right? So we don't want to do that. Say we want to just keep this nums afloat, to save on space. Well, what we could do is simply put a f next to these numbers, and we force convert uh, the 9.8 and 8.5 into a floating point number. So why Java does this is it's a strongly typed language, meaning that in this particular case, any decimal number, it assumes it's a double. So if you just leave 9.8 as just 9.8, it assumes that you mean to convert 9.8 into put 9.8 into a data type that's a double, and it throws out an error that, hey, num2 is not a double, it's been declared as a float. You really mean you want it to convert it to into a double. Well, no, in this case, no, I don't. I just force it into force 9.8 into num, and then we run the program, and as it's getting done compiling, it will spit out a number 8.3, which is a floating notation point, floating point notation number that we forced into a float data type, because we know we have uh, accuracy in the float data type. Uh, it can hold uh, a number in the range of 7 digits of accuracy. We don't need the 15 digits of accuracy in a double, but uh, it's a quirk of the programming language of Java. So as I alluded to earlier, in the previous video, we will go over the different arithmetic operators and the order operation, and simply the same order of operations that you learned in algebra. So let's convert these back to integers to make it simple and easier to follow along what's going on. And we'll say, nine, we'll do 8 uh, and 9, and then say we want to add a new number or new integer variable, do num4. We'll declare num4, and then we want to set num4 num4 equal to 2. And then we want to multiply num1 plus num2, and then times num4. And based on the order of operations, the multiplication will happen first because that's the higher uh, order of operations. So it'll spit out num4 times num2. So it'll be num4 times num2 would be 9 times 2 would be 18 plus num1, 18 plus 8, it'll be equal to 26, right? So we expect num3 to be spit out to be 26, and we'll recompile this code and wait for the runtime, and right here it'll spit out 26. All right. So and that's important to remember, that that certain operations will happen first before other operations, um, unless you force it to happen differently, in which case you could say you want to put parentheses around num1 plus num2. So you want this to happen first, num1 plus num2, then multiply it by num4, in which case num1 is 8 plus num2 is 9. You'll get 17, multiply that by 2, and you'll get 34. So 34 will pop out in num3. So let's run this program again. And 34 miles pops out. So two vastly different outcomes if just by just adding a parentheses. So you already know this from um, from knowing the associative properties and order president, uh, and also you have something called unary operators. So the plus sign can be is a binary operator. You need an operand and operator. So the operands here are num1 and num2, and then the plus sign is the operator, and then the multiplication sign is an operator too. Say you wanted num1 to be negative. Uh, a negative sign is a unary operator. So you don't need any other operator besides the negative sign here to actually run to convert num1. It'll be -8, but then you'll multiply num2 times num4 first. It'll be 18 plus -8. You'll pop out 10, positive 10. So let's run this program again, and you'll obviously get positive 10 miles, right? So with that, you know that the negative is a negative is a unary negation operator. So let's focus a little bit on the math class. Now, the math class is built into the Java API and provides you the ability to, uh, do a couple very powerful tools. We'll just go over just two of them. We'll talk about taking a number to a power and square rooting a number, which are very basic but important things to do, especially doing high level math. So let's erase all this, right? And let's say we want to call out math. Math is already built into the background Java program, so you don't need to import anything. We'll talk about importing stuff when we get more towards dialog boxes and to the scanner classes when we're talking about reading inputs. So, but either way, so math, as you can see, has a whole bunch of methods. The math class is built in, but it has a whole bunch of methods built in here. So we'll talk about let's do power first. So pow, you need let's say we want to square root num1, or we want to take num1 to we want to square it, so we'd use num4. And uh, here here that works. And in this case, so it'll be math.pow num1 to the num4th power, right? But as you can see, we're popping up an error. What's the error? Well, the math class POW takes two double arguments and it returns a double. So we want to really convert integer into a double, and then it uh, gets rid of the error, and we'll run the program. It'll take 8 to the um, second power, and it'll be put out 64.0 miles, right? And now let's say we want to do square root. Say we want to let's erase this, and say we want to do square root of a double, and we want to square root 9. So we want to do num2. Or we can actually put the literal 9 in there too, which would be about the same difference. Let's run this. And we'll get 3. But we can also put the actual number, the literal 9 in here, and then get the same result, but we wouldn't be using um, any of the numbers that we already declared in the uh, the the variable declaration up here. So as you can see, the math class, if you erase all this, if you just go math dot what have you, there are a ton of different variables or methods and different type of variables you can manipulate with, or different data types you can manipulate with this math class. Super powerful. uh, I would say do a little bit of research what you can and cannot do using the math class. And we'll just we'll just say that a lot of the research you will do in won't be covered necessarily in the book, but the information is uh, is definitely freely available for you if you want it. Also, reach out to me if you really want to know. Either way, that is all for this lesson.